Welcome to the Southeast Welding Academy. My name is Wisdom Shapard. I'm your AWS certified welding instructor. And this video is week 4, episode 2. And in this video, we're going over the importance of your root pass. Okay, so your root pass is the first weld bead, right, placed in your joint, right? It's one of the most important stages in welding for several reasons, right? One, because it forms the foundation of the weld. The root pass establishes the first bond between the two pieces of metal, right? If the root pass is weak, incomplete, or defective, all subsequent passes will also be compromised. You want to ensure your full penetration, right? A proper root pass ensures the full fusion at the root, no gaps or unfused areas, and a strong structural continuity. Poor penetration can lead to cracks, leaks, especially in pipe welding, and joint failure under load. Number 3 on why your root pass is so important and crucial is because it controls your weld shape and alignment. Right? A good root pass helps maintain correct alignment of the joint, consistent root reinforcement, and proper weld profile. Okay, if the root is uneven, the next passes become much harder to control. The 4th reason on why your root pass is so crucial and important, because your root pass is critical for pressure containing systems, right? In pipe welding, the root pass is the only internal weld bead directly exposed to the working pressure, right? Any defect, such as suckback, porosity, or the lack of fusion, can cause catastrophic failures. A properly executed root pass reduces the risk of lack of fusion, incomplete penetration, burn through, undercut, slag inclusion, really your weld impurities that you do not want. It sets the stage for defect-free fill and cut passes. Overall, your root pass is it's the most critical pass in welding because it provides the structural base. It ensures penetration and fusion. Number 3, it prevents failure defects. It affects the integrity and pressure. It affects the integrity of pressure systems, and it determines the success of all subsequent welds. Now I'm about to show y'all what a good root pass, or how to acquire a good root pass. It's really the same as any other video. Taking your time to create your weld bead. Taking your time. It's really your current. Make sure your current is set to the right current. Right, you got the right current, and now it really falls on your comfortability, your oscillation type, your oscillation speed, and your travel speed. That's it. That's all. You got your good current, your good amps, and you got your good spot. You know what I'm saying? You laying it, you comfortable, and you got your good rhythm. There should be no reason why you don't have a good weld. Okay, so let me get started on this here. Okay, so with the root pass, I'm gonna show y'all the motions with the root pass. It's just oscillation. Okay, what you're doing, the concept of the root pass is you're coming down. When you start your arc, you're using this backing strip, right? So you're letting your puddle build on this backing strip. Then when you bring your puddle up, you're in that little corner, right? The root pass is to be in the corner, right? Just to connect these two metals, these two walls, okay? So you're sitting right here, and you kind of just touching this wall, 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 touching this wall. But see, when you start vertical, when y'all going vertical, look at our previous videos. We teach you guys the pausing method, right? So whatever oscillation you're doing to do your root pass, whether that's the crescent method or some zigzag methods or some upside down triangle method, you will always pause on your sides. So if I jump to this side, I will pause for a second. Go to that side, pause for like 2 seconds. Go to this side, pause for like 2 seconds. Go to this side, pause for like 2 seconds. Okay? And when you carry out your rhythm all the way up, it will just ensure you a nice strong weld, a nice strong root pass, okay? The only if your rhythm is down, right, you got your rhythm down, the only other thing you need to worry about is your current, your travel speed, your oscillation speed, and your oscillation technique. That's it, that's all, okay? I hope you guys learned something in this video. This is the Southeast Welding Academy. My name is Wisdom Shapar, and I'm your AWS certified welding instructor. I hope they see you in the next one. Peace. Alright, so I'm gonna show y'all the root pass on the T-bar. Let me show you guys what the T-bar looks like. This is what I will be running the root pass on. Okay, I'll throw a half pass on there just to show y'all the concept of the root pass. Really, your root pass is the first pass. Okay, your root pass is the first pass when involving a multi-pass weld process. Okay, so in this case, when y'all get to the T-bars, y'all be running a root pass, a half pass, and 3 stringers. That's a multi-pass weld process. Okay, but I'm just showing y'all what I'll be using. Right, the root pass is to get the complete fusion between these two metals right here. Right, so I'm getting the root in, connecting these two metals. Right, I'm gonna show y'all a good root pass and a bad high pass. Smell like that rice and chicken. I'm tripping. Oh, who bought food? Oh yeah. Who? That's that come through with the food. I forgot I had these dark shades on. I could barely see. Like just barely. Okay. But really, welding is just taking your time, you know what I'm saying? Having good rhythm, having good oscillation speed, good travel speed, good current, and you know how to weld. Just focus on, when you're welding, you should just be focusing on your puddle. Your puddle will tell you everything, literally everything. Your puddle will tell you if you leave an undercut. Your puddle will tell you if you stand too long. Your puddle will tell you if you have too high of amps or current. It will tell you if you have too low of a current. Okay, it will tell you everything. Just pay attention. Okay, I'm gonna finish this out and then I'm gonna show y'all. See how I'm leaning? Never have your feet directly under. just because I don't want to risk any welding defects up there or any more. More than I already can. What's up, y'all? Finish this real fast. This is still a good root pass. I ain't not gonna lie. Y'all let y'all easy as 1, 2, 3. So y'all, this is how my root pass came out. I do not have a grinder at the moment. I really try my best to get all that out. Now my plan here is to show you guys what the difference between a good root pass and a not so good pass, what they look like. Okay. So right here I'm gonna run with 2 passes of a travel speed. Okay. Get a little bit of undercut in there. I see I'll run a little hot too. Try to get a little porosity in there. You gonna see. Obviously, see that. You guys can't see what I'm seeing, but it's literally, I can see all the undercut. I can see all my undercut loose. And I can't really sit there too long and fix it because I might sit there too long and burn through the glue. So right now I'm getting a lot of extensive penetration. I'm getting a lot of undercut and I'm getting really up. I'm getting a lot of burn through it. I'm pretty sure I'm on the other side of the plate by now. Okay? We're about halfway there. I think I'm halfway through the plate. But this is to show you guys. You know what I'm saying? This is to show y'all. Yeah, like I could see the penetration through my whole other window. You know what I'm saying? Okay. Am I just what the? Okay, the V looks proper only because I had a good travel speed, okay, and a good oscillation speed. But other than that, I was trying to leave undercut. You could see the undercut, you could see the slag. I mean, you could see some porosity, and you could see how deep, right? How the excessive penetration I was getting. But that was, even when it was blowing through the plate, I was sitting there letting it real build up. Okay, so that's why it still looked like a good weld. But this has excessive penetration, and I know that. Okay, look at that. Y'all see that porosity, right? The voids around the wheel, that's a lot of porosity. Okay, you can see the undercut, right? That's a groove right there in the wheel. I want the groove right there, and then look how deep that crater is. Okay, that comes from burning too hot. That's excessive penetration. Okay, excessive penetration can lead to cracks as well inside your wheel. Okay, undercut can lead to cracks inside your wheel. We're gonna try to finish this out. Hopefully it don't burn all the way through. But if it does, that just shows y'all what happens when you burn too. As a matter of fact, now I'm gonna turn it down. I'm gonna turn it down too low. So at the bottom half is burned too high. The top half is burned too low. You guys gonna see the difference. Okay, I'm still using the fast travel speed with this code. I'm running code and I'm running the fast travel speed to show you guys what this loop actually look like. I got a very small movement between my arc alive with this code current speed. See how hard it is to keep my rod on with this pull current. So now I can already show you guys I left undercut with the pull current, and also my bead came out way skinnier than the bottom. And way flatter. Guys, look how flat my bead came out. Look how flat that roof pass is compared to the bottom. Okay? And I probably, with a low current, you probably get a less, you get a lack of fusion. I mean, a lack of penetration to the back. Okay, so I got some undercut in there, which came from the lack of fusion. It's a real flat kind of bead. It's a flat root pass, which will cause, which means it doesn't have enough reinforcement, right? Which means it could be weak, a weak root pass. So yeah, y'all see the difference between a strong root pass and a weak root pass, strong root pass, and a weak root pass.